Hello again, I'm Param Singh. Hope you guys are doing well. In the last video, we learned how to design functions that consume recursive data structures such as a list. In this session, we are going to employ that design recipe to compute the length of a list, or in other words, to compute the number of elements in a given list. Starting with the signature first, let's write the spec for this function, and let's call this function as list length. Okay, so list length is going to consume a list, and for now let's just consume a list of numbers, and it should produce an integer, right? So it will consume a list of numbers and it should produce the integer, which will be the number of elements in that list. So this becomes our signature. So now let's write our documentation, meaning the purpose statement. Compute the number of elements. So I'm going to say length in a given list. So this becomes our purpose statement. The third step is to write the stub. So we start with the def list length and what it should consume. So it should consume a list of the type that we have defined in the signature. So I'm just going to type 1 inside square brackets. That becomes our list, and it should produce an integer. So we are going to write 0 here. So that becomes the simplest stub for our list. The third step is to write some tests, and that will also highlight the example cases, will help us think about the solution of the problem. So we are going to say test empty list, right? And this we are going to say assert my list dot list length, and if it is an empty list, it doesn't has any elements, so that should give me 0. All right, and then we are gonna write one more function for, we're gonna say one element list, and in this case let's say we have a number 10 here, and it should give me 1 because there is one element in there. And then let's write a test for a 2-element list, and here let's put here 10 and 20, and this should give me 2. So these are our test cases. We'll go back to our implementation file, and once very quickly we'll go to our console here and do mix test, and this is purely to make sure that our tests are well formed. And we are seeing some function clause errors, which is fine because we have to write some function clauses. So this is okay for now. Let's go back to our implementation file, and this is where now the design recipe comes in. So let's look at it once again to review. So the design recipe says we have to list both non-self-reference and self-reference cases. That's our step 1 here. So this becomes our non-self-reference case, and we don't say we are gonna do anything yet. This is just the step 1 here. And then the second clause of list length is gonna be the self-reference case. So head of the list and tail of the list, and we are going to do something with it. So the two pieces of data that we have available to us for the self-reference case is the head of the list. And if I pause, do you remember what is the second piece of data? So the second piece of data is calling our function on the tail of the list. So list length, tail of the list. So these are the two pieces, head of the list and list length, tail of the list. So this defines our step one. We have listed both cases. The next step is to define the base case. And let's think about it. What should be the body for an empty list? Once again, we can get some help from the example tests we have written. So we are saying the empty should give us 0, and that naturally follows the logic of the length of the list. It does not has anything in it, so the answer will be 0. So this becomes our base case. The second is the self-reference case or the recursive case, and here once again remember, we are not going to touch this piece. We are not going to split the tail apart, or we are not going to remove this function call from the tail. So this is the natural recursion part, and we have to keep this as it is. So we have two pieces of information, and we are saying how can we use these two pieces to find the length of the list which has some elements in it. And one intuition will be that the function, the list that has a head and a tail, should be 1 for each head that it extracts plus the list length for the tail of the list. So this becomes our implementation. And going back to our steps here, so we have defined the base case, we have defined the self-reference case, and then say mix test, and all our 3 tests are passing. There are some warnings, but those are related to unused variables, and we'll look at that in a bit. But the fact that all 3 tests pass give us good confidence that our function design is working. So the fact that now we have not used this piece directly in our expression, Elixir is complaining that, this is not used. Do you want to ignore it? So what we want to do is we'll put an underscore before it, and this is more readable instead of just putting the underscore, which is discarding the head. Here we are saying underscore HD. That means we will be otherwise referring to the head, but we are discarding it. We are not going to use this variable in our expression. The other piece of generalization we can think of it is that here we are saying, okay, it's taking a list of numbers and producing an integer. Would this function work differently for a different data type? For example, if I have a list of atoms, or if I have a list of strings, or would it work the same? In this particular problem, it so happens that the length of the list is the same regardless of the type. It just depends on the number of elements. What that means is, instead of number, we can just say any. It can take any type, and then it will produce. We can just extend our tests for 2-element list, and we are gonna say, let's add another test case, 2-element list of atoms, right? And then here 2-element list of integers, right? And here we're gonna say okay, error, or we can put another one, unknown. And since there are 3 elements, this should be 3. So let's go back and run our test again, and all 4 of our tests pass. So this becomes our final design of the recursive function to compute the number of elements in a given list. This is extremely important concept in computer science in general, but also very interesting way to solve problems in which the size of the data is not known in advance, that is arbitrarily sized data. So let's solve the second problem, the sum of numbers in a list. So it consumes a list of numbers, and the answer is going to be the sum of those numbers. So I would once again highly encourage you to pause and think about it. In the next video, we are going to present a solution, but it will follow the exact same steps as we have done for this first problem. And once you have given it a good try, review the next video, and things will start to come together when we review it again.